start. Thank you very much for joining us for this session, Innovating Data Science Pipelines Through Collaboration. I would like to introduce and ask my esteemed speakers this afternoon, Albert Park and Mike Harnish, to introduce themselves and tell us a little bit about your role. So Al, why don't we start with you?
Yeah, hi everyone. My name's Al Park. I'm the Senior Director of Bioinformatics Engineering at Moderna Therapeutics. I joined there March of 2023, so I'm not too much of an old-timer the way that Dave Johnson earlier had been. Yeah, bioinformatics engineering is pretty niche kind of functionality within the research computational sciences scope. I've been working in the industry for over 2 decades now, and I've worked at both small companies as well as very large organizations, and so everybody's at different stages, and at this point in Moderna's life, they're kind of going through the natural growing pains of migrating from a startup phase company into a more mature company at this time. So.
And Mike?
I'm Mike Harnish. Hi, everyone. I'm the president and co-founder of KSM Technology Partners. We are a systems integrator and Domino consulting partner based here in the Philadelphia area. Last year, we celebrated our 20th anniversary.
Wow.
And we are, our experience with Domino has mostly been with statistical computing environments, implementing statistical computing environments and integrating Domino with our customers' systems. And as we'll see, this was a sort of a stretch for us to learn a little bit more about a different area of more research than we had worked with before. So.
Albert, Al, to set the stage, can you tell us about what were the main challenges that Moderna faced that set the stage for the project?
Sure. So I know many in the room are not bioinformaticians, so to give a little context, so in the bioinformatics world, many of what you actually just saw a little bit from a flow perspective that Domino provides, the bioinformatics community had actually already kind of consolidated to in multiple different type of workflow languages. And so a lot of the kind of bioinformatics development process is really utilizing a single, let's say, EC2 instance that has a lot of resources, because in a stepwise manner within the workflow, people, when they're doing their bioinformatics development work, they're usually resourcing for that one task that really requires a lot of horsepower to be able to get through it. And so you can imagine that a lot of kind of wasted computing resources checking out a very large instance to do your development work can be problematic. And so Moderna has been making a very concerted effort to try and be cost conscious in the cloud infrastructure. And so Domino, being able to try to do development work using Nextflow as the language within Domino's environment helped streamline some of those costs and efficiencies that we were lacking from a development process.
And that helped you consolidate some of the research with the work pipelines essentially in the same environment.
Yeah, that's right. Exactly.
Love that. Can you give us an overview? What did the team that helped support you look like, and like what type of work did KSM help you with?
Yeah, sure. So we got introduced to KSM by, through Domino, and part of the problem scope, as I just described, is that bioinformatics scientists or computational scientists were actually doing their development in single EC2 instances, and to mature a bioinformatics pipeline, which was perhaps executed as a Jupyter notebook assembly of tools, into a more robust engineered solution that leveraged something like Nextflow. We wanted the ability to do that development process inside of Domino to leverage a little bit of that jobs functionality. And so being introduced to KSM, we said, hey, this is the workflow language that the bioinformatics community is really consolidating against. It would be great if we could leverage the jobs functionality within Domino. Could we actually get a Nextflow compatible plugin into Domino that took advantage of the jobs functionality within it?
And Mike, how did you approach that? It sounds like they had an existing code base and you needed to enable it.
Yes. So first, I remember when I first talked with Al about this, we were talking about pipelines that we'd worked with within Domino for statistical computing that can take minutes, hours to run. And I happened to mention that, and Al said, I think you said days, think weeks for some of the larger pipelines, the production pipelines, the amount of processing, the amount of resources that they're using. So that just to set the scale for what, that's an order of magnitude or a couple orders of magnitude more of a problem than we'd considered before. So as we thought about what we wanted to do, by the way, we don't have a lot of slides here. So there's, I think, one, two, oops, I'm going the wrong way.
Opposite direction.
Thank you, sorry. We had some objectives. What did we want to do to enable Al and his team to accomplish their work? So the first one was Nextflow pipelines use a lot of highly specialized tools, and they're lots of different varieties. They're written in a variety of languages, and they're stressing, the Nextflow community really stresses using containerization so that you have a very reproducible environment to execute these in that you can spin up quickly and use. We wanted to be able to support all of that tooling from within Domino as well. So that was one thing we certainly wanted to do. As Al said, we wanted to enable scale up through parallel process execution. We could have, if you're familiar with Domino, we could have started a workspace, a very large workspace with lots and lots of memory and lots of CPU allocated to it, and we could have left it running for days. And there would be some times when, a lot of times, when it wouldn't be used at its full capacity, and it would be a waste of resources and a waste of money. There also would be times, however, when there are a lot of jobs that are expensive that are happening in parallel, need to run. They could easily tax that environment and keep it to the point where it couldn't grow, and some jobs would actually have to be retried or die because they'd be starved for a lack of resources. So we wanted to be able to enable those to scale up using the scalability of the cloud and Domino's underlying infrastructure with Kubernetes. We wanted to be, as I said, we wanted to economically marshal them so that when we weren't using them, then we would spin them back down so we wouldn't be paying for anything more than we needed to accomplish this task in a pipeline at any given time. We certainly wanted to do this without having to customize Domino, but most importantly, looking at the Nextflow pipeline code, we wanted to write this so that we didn't have to make any changes to it at all. That was the real challenge for us. I didn't want to have to tell Al, well, we got it working, but you're going to have to rewrite all of your pipelines. that wouldn't have flown. So we wanted to be able to sort of externalize this configuration so that everything worked without any changes like that. So.
Can you tell us more about, you mentioned the bioinformatics community coalescing around Nextflow, but what was especially appealing to you and your team at Moderna around it?
Yeah, sure. So the bioinformatics community starting to consolidate or has been consolidating around Nextflow as the workflow language. And part of that has been actually open sourced bioinformatics pipeline. So there's a community, there's a Git repo, for example, on GitHub called NF Core, and it has a whole host of ready-made bioinformatics pipelines to address different types of sequence-based assay data processing that is contributed to by many of the thought leaders in the space, whether that be academics or institutions that are contributing to that as a mechanism to help optimize and be inclusive of many of the different tools that could be used at each individual step within the pipeline itself. And so, I think generally, and it's kind of a little bit of the theme here, is data reproducibility, right? So in the research space, especially in the bioinformatics field, maybe a decade ago or maybe 15 years ago, people would make publications and have really struggled trying to reproduce the type of data analysis and work that was being done. But by having consolidated to this kind of community-driven effort to standardize to certain types of pipelines with the flexibility of switching between tools at certain steps, you have regained that reproducibility, right? And I wanted to touch on a point that Mike made earlier about really allowing the engineering team to take advantage of the Nextflows, specifically within Domino. It was really important for us to not have to deviate too far away from already the engineers being very comfortable using Nextflow as a workflow language. And to that point, maybe a little bit too into the weeds here, but essentially one of the only steps that you actually have to do to modify the workflow itself is to set up one configuration, one set of configuration file. Once you've done that, the Nextflow workflow will execute in Domino just like it could execute in a single EC2 instance or just straight up AWS batch.
Can you provide us some examples now that we talked about that, how the pipelines help you? Where did you see special gains in efficiency? Yeah,
sure. I mean, I think Mike has a slide where we, as one of the example pipelines that we asked Mike to stand up for us in our Domino environment is a very standard pipeline, an RNA-seq pipeline that's used heavily by the community. Internally at Moderna, it has many of the tools that Moderna specifically wants to use. And so we had him essentially try to take the public version of the RNA-seq pipeline and deploy it within Domino. It would have to recreate all of the specific Docker images and bring them into the Domino environment so that it would execute natively within Domino using a test sample case, samples of data. And he was able to successfully show, and KSM were able to successfully show that they could do that, which is really critical because for Moderna, what we actually do is we leverage some of the community-driven pipelines, and we will fork away, not because we necessarily want to fork away from the pipeline itself, but because there are some inefficiencies built into how the pipelines are built in the community because they're trying to service everyone globally, essentially. But within Moderna, we want to really be cost optimized. And so we will actually streamline or reduce some of the flexibility in the pipeline or sometimes make even optimized improvements to the workflow itself and deploy it internally. So that development process is really critical for us with a cost consciousness on mind.
That's amazing. And what role does NF Core, you mentioned it, what role does it play in simplifying the creation and execution of the pipeline within the Domino ecosystem?
Yeah, I think I mentioned this a little bit before, but I think for many of the sequencing-based assays, the community on a particular assay platform, on a particular type of instrumentation that's being utilized to generate sequencing data for a specific type of purpose. In academia, usually they will start with something, and then commercial entities, industry will latch onto that and improve it, working hand in hand with academics to try and improve that workflow and that pipeline. So, a community-driven effort to develop that and to bring in multiple different tools at multiple different steps is obviously a easier path for trying to gain the advantage of a community-driven effort as opposed to trying to implement something custom internally where you would have to do a lot of reading to understand these various tools, to understand whether or not they were compatible, which ones were better in certain situations than others, and you just get them all for free, kind of with some documentation, so it's nice.
And from my perspective as an integrator, if we had to work with custom data or if we had to work with proprietary data, it would have taken us a long time to get access to that data. If we had to work with not just Moderna, any of our customers' tools, their own GitHub repositories that had their code, it would have taken time for us to get access to that. Because all these workflows are open source. They're public. They use publicly available data from that we can use. And they're built in, crowdsourced, documented. So it's ready used for us to say, here, run this. Now let's make it run in Domino. So that's a really, really big advantage for us, is to just get up to speed and hit the ground running.
I think the world of data science where Domino is in at large, we're kind of seeing right now, we have a few folks inside of the company that actually do something similar in the wild world of Gen AI, where we take research papers right now and we implement them inside of the platform. So it's good to see that we're standing on the shoulders of giants here. Could you discuss any notable outcomes or successes as a result of this collaborations? You mentioned improvement in platform optimization and efficiency, time reduction, cost reduction. Can you share some figures with us or anecdotes?
Yeah, sure. So all of those, of course. Like I mentioned before, doing development in a single large EC2 instance to develop some of these Nextflow-based workflows is pretty cost inefficient. However, when you're doing your development within the NextFuse-enabled Domino environment, you really gain that you're able to leverage and kind of appropriately resource individual steps. So a particular tool of a specific data size as an input would only require, let's say, like a 2 CPU, 4 gigabytes of RAM, but you can scale that parallelized because you're passing through maybe 200 samples at a time for that one execution. Whereas a step further down is perhaps maybe not parallelizable, and it's aggregating all the information together. Nextflow, the language, is doing that aggregation layer, but for that particular task execution, again, you could define that task as saying, okay, now I need a much larger resourced virtual machine to execute that specific task. And so being able to customize and optimize those specific task level details really helps from the development process to be cost conscious. And as I mentioned, Moderna is trying to be cost conscious in the cloud computing environment. And so that was one of the major drivers for being able to do this.
Yeah, and one of the ways that works out. So Nextfuse, by the way, we haven't introduced the term. Nextfuse is the name of the product, the plugin that we developed to allow Domino and Nextflow to work together. One of the things that we did that we didn't mention is this being able to customize for every step, either individually or based on other attributes of the step, tags that are associated with the step. We can use that to select what hardware tier we use. So whether we're throwing a big instance at it or a small one, what compute environment that we use, which has the tools that we need. So that's a big part of enabling that. Yeah.
And now, when we talked, you also mentioned there was a data security element to the use of Domino.
Yeah, that's right. So internally, some of the time, we actually have some portion of Moderna employees have access to vendor-provided data, and it's tightly controlled who actually has access to that primary data, and restricted to maybe a handful of people. However, the process data at the end of a pipeline should be accessible to all because it has been processed, and whether it's metric data that come out of it, some count matrix data, et cetera, so that data scientists like yourselves could potentially leverage that as a new data set and combine it with existing data sets as well to perform some analytics. And so, being able to have access to the restricted access data, but then allowing Domino to process that data, ultimately pumping out the process data for others to share, storing it as a data set, and then enabling everybody within a singular company to gain access and be able to search for that process data has been pretty powerful.
Love that. No project goes completely without hitches. Can you share some of the challenges that you faced during the integration? Because open source is not as smooth as it always is. But what were some of the challenges? How did you overcome them?
Yeah, sure. So Mike touched on this a little bit earlier as well. But the bioinformatics community for each of these tools, usually tries to hyper-optimize the Docker container or the Docker images themselves. So typically what you'll see is a single tool installed with an OS layer, and that's pretty much it. It expects an input and an output for execution. Sometimes it's optimized where it has two tools installed, where it's trying to stream the output from one tool to the as an input to the next tool for speed and efficiency purposes. But generally, these Docker images are very, very minimized for performance and execution efficiencies. But they're all deployed, usually published in the public and open domain. In order to get them into Domino, there was some struggle because Domino itself is using containerization, and you need a layer. The Domino needs its layer to be able to track what is actually happening at the container level. And so one of the challenges was, how do we actually pull in all of these publicly deployed and already established Docker images and bring them into Domino's environment so that we didn't have to do too much work and execute there. So that was a challenge that we tossed back to Mike, and Mike addressed.
Yeah, so what we did was we built a DevOps pipeline to enable Nextflow pipelines, so we scripted the creation of these tools so that if a new one comes online, and the new ones are being released all the time, we have the ability to incorporate those in the platform as well, just by adding them in, storing them in the container registry that's associated with Docker, and then being able to use it in future pipelines. Now,
and you use Domino APIs in order to stand them up inside of the platform.
Yes, we did. We used the Domino APIs, and that's a really important point. This is all enabled because of Domino's rich APIs, and I think that's one of the things that's underappreciated. I was just telling somebody about this at lunch. It's one of the things that's really underappreciated about Domino is, yes, it's a platform. It has a nice user interface, but also has a rich set of application programming interfaces that enable this sort of integration. And whatever you're using it for, you're going to use those in any hardcore or even mildly and even a simple integration effort. Yeah, it's going to be tough. They're good to have.
I was actually looking around to see one of our engineering leaders is here. I was hoping he would hear that in his ears, because he was a big proponent of the API. Yes, I'm glad about that. To close and then to open you guys to questions from the audience. What future directions and opportunities do you see downstream at Moderna and beyond that, Mike, now that you guys are Nextflow experts? What do you guys see in the future?
Yeah, so the Nextflow language itself continues to develop, and I was just telling Mike a little bit earlier, the current version of Nextflow that we're using is DSL2. The community is already working on a DSL3 version that is probably going to be published at some point, either at the end of this year or beginning of next year. And it's supposed to really lower the bar for entry for new people introduced to Nextflow as a workflow language to be able to really quickly develop these pipelines and be able to deploy them at scale. So that's kind of really the next step. There's a lot of optimization work that we do internally at Moderna. So there are custom-built pipelines that we optimize. And then also, and there was a little bit of touch on this, but I'm sure many of you are using things like AlphaFold 2, and AlphaFold, the next version of AlphaFold was already released. But if you actually understand what the code behind looks like, it's really, from an engineering perspective, a suboptimal engineered piece of code. And so one of the things that we attempt to do is, because there are so many heavy users of AlphaFold 2, and it's a constant struggle to keep it running correctly in the environment that we have, is to actually refactor that code as a Nextflow-based workflow and as a Nextflow-based pipeline. And so one of the things that I've asked my engineers to do is to, once we get to that point, to republish it back out to the open source community, because there's nothing proprietary about that. We're just doing it for our own efficiency's sake.
And then the community can improve on it.
Yeah, that's right, exactly.
From our perspective, next steps, I think, for us are to keep Domino keeps coming up with new releases, so we have to keep upgrading Nextfuse to make sure that it accommodates both new releases of Domino and new releases of Nextflow as it comes out. That's one thing. One of the things also was we were talking about this earlier that I've observed. This is a very mature community, the bioinformatics pipelines, especially the way that they're in NF Core. There's a lot of reuse. It's not just they've come around to the idea of pipelining. They've built these reusable tools, and I think that's something that the other, from a statistical computing environment, something that we've talked about, pipelines. GSK was talking about pipelines, and I think actually, especially now with flows and Domino coming out, as we saw demoed earlier this morning, is an opportunity for other communities to use that built-in functionality to create these packaged pipelines that are metadata-driven based on what transformations you need to do on the data and what derivations you need to execute. So that we can do this in a much more standard way. Obviously, as Al said, there's probably going to be, we'd like to take some of these pipelines and customize them for use in any individual customer, but we certainly have that baseline to work with. And I think that's actually a really exciting. I'd love to see what this community has done and take that to a broader scale.
Amazing. Thank you. Any questions from our audience? Anyone wants to? Caroline.
I have a question for you, Mike.
Okay.
Because you've worked with the statistical computing environment community, the biostats programming for submissions.
Mm-hmm.
You've worked with bioinformatics teams. There are some overlaps, although there are some pretty big differences. But, and you mentioned how mature some of this bioinformatics community is with respect to open source and collaboration on these pipelines. Do you think that there's an opportunity there for the biostatistics community to do something very similar? We have like the Admiral,
Right.
project and Pharmaverse, et cetera, other open source communities, to build some of these data pipelines, kind of like we have STTM, Atom, and then TFLs, some out-of-the-box type utilities like that, in the same way that bioinformatics community has.
Yes, I absolutely think that's the case. I think the fact that we have initiatives like the Admiral initiative and also a lot of the work that CDISC is also doing to standardize on a lot of these formats and processes is also would enable that as well. If everybody's sort of shooting, if we have one target that everybody's sort of aiming for at the same time, it makes it a lot easier to develop shared infrastructure like that. So yeah, I think that's absolutely a possibility. I think we should be moving towards it.
Mike, when you guys were developing the Nextfuse, were there any surprises you found in either working with the data itself or with Moderna as a client? Not to put you on the spot. But.
No, it's a good question, and this is going to sound really cheesy. I'm not just saying this because Al's working is sitting next to me, but actually, no. I was amazed at how little friction there was. Again, a big part of that was because the specs were out there. Here's RNA-seq. Here's Domino. Make it work within Domino, and tell us what we need to do. I think the only source of surprise was first the sheer number of compute environments that are used in any images that are used in any particular pipeline, especially one as complicated as this RNA-seq pipeline. So we sort of had to. I think one of the things we didn't anticipate is how much work we would need to do to bring those into Domino so that we could work with them. That's why we just immediately, Dave, my colleague, put that into a pipeline so that we could make that happen really quickly and update it as we needed to. That was the one challenge I think we didn't really foresee, but we should have.
So, in the past, I think within biostats, we've looked at developing these pipelines through like very well-defined ontologies of this in SDTM maps to that in Atom and this to this concept on a display, and you really had to have those linkages to make that work. And now with LLMs and AI, obviously that opens up a new some new opportunities. So I'm wondering what you think is the best way forward to adopt some of these things in the biostats area and develop those pipelines.
I think as far as developing those pipelines, yes, I think AI can be a big help. But again, as we saw, when it comes to reproducibility, that's not something that is a great strength of these approaches. So I think, I'm not the foremost expert on this by any chance, but I think we can certainly look at how can we leverage AI to help us make that jump, to create those pipelines. But then I think at some point in time, those tools are going to have to generate code or something that we can then be able to present to an auditor. And when they say, how are these derivations performed, I can show them this R code or this SAS code and say, here's how it was done. It's my thought off the top of my head. It's a really good question, but yeah.
Did you try generating pipelines with generative tools?
I mean, you can
Please hold.
yeah, you can do it, but it still requires an actual developer to make sure that it's actually executing the right way.
Is there enough body of DSL code there to train it?
Slowly, yeah,
Really?
slowly, yeah.
Any other questions? Sounds good. Thank you so much, guys. It was a pleasure speaking to you. And
Thank you.
congrats on the project. Thank you.